Greetings, M squared here today. Today is our second day on parallel and perpendicular lines and their slopes. Today we're going to have given an equation and have an equation and kind of look at the equations, not just the slopes, to figure out if lines are perpendicular or parallel. So let's remember, parallel lines have equal slopes. Perpendicular lines have opposite reciprocal slopes. That means you're going to take the opposite and flip it over, right? We talked about opposites and reciprocals yesterday. Opposite examples are 4 and -4, or -1/2 and +1/2. Two numbers that are on opposite sides of 0, the same distance from 0. Reciprocals happen when you flip over the number, or basically the algebraic way is you take 1 and divide it by that number. That's a little more complicated way. So we're just calling it like reflippical. We're just flipping it over. We'll get into more of that in Algebra 2. But that is the definition of the reciprocal. So if I had 3, the reciprocal would be 1/3. And if I had 5/2, the reciprocal would not equal. The reciprocal would be 2/5. So when you're finding the slopes of perpendicular lines, you're changing the sign and you're taking the reciprocal. So just to recap, here we go. Slopes. If my slope is 1/4, because that's in slope-intercept form, then I know that the slope of a parallel line is 1/4 because parallel lines have equal slopes. And I know that the slope of my perpendicular line to that line would be -4 because I changed it from positive to negative and I flipped it over, 4/1. Here my slope is 3, so I know my parallel line is going to have the same slope, and I know my perpendicular line is going to have the negative reciprocal slope. And then finally, this one's in standard form, so I can use my shortcut or change it to slope-intercept form. So my shortcut is -a, sorry, that would be -2 over b. That's how I find my slope, so that would be 1/3. If you didn't want to do that, because you didn't remember the formula, you can always add 2x to both sides and then divide by 6. And you still get 1/3 as your slope. Just depends on how you want to do it. So we know our slope of this line is 1/3, so our parallel line to it is going to have a slope of 1/3, and the line perpendicular to it is going to have a slope of -3. Okay, we are going to do some problems, kind of like the ones you'll have on your homework. So you're going to determine if two lines are parallel or perpendicular. And how you're going to do that, number one, you're going to find the slope of every line. You're going to know that if they're equal, they're parallel, and if they're opposite reciprocals, they're perpendicular, and if they're neither of those things, then they're something else. So our first question today says, which equation represents a parallel line to this line? Well, if it's parallel, that means the slope has to be the same. Again, you have options there. I'm going to use the -a over b formula. Remember, I'm talking about you only use this formula when you have standard form. So the number in front of x is a, the number in front of b is, the number in front of y is b. And why do we have this formula? Because if I was to get this in slope-intercept form, I would move that to the other side by doing the opposite of it, right? So if it was positive, I would subtract it. If it was negative, I would add it. And then I end up dividing by b. So this is just the shortcut of what you do if you got this into this form, this slope-intercept form. And notice that's a lowercase b, that's upper capital B. Those are not the same. All right, so if I do -b over a, I'm sorry, if I do -a over b, I get -2/3. So I'm looking for the slope that has -2/3. And these are nice and beautiful for me. They're already in slope-intercept form, so I can tell this is the one. So I'm going to check that little box. Okay. Next one says, how about if these, I want a line that's perpendicular. Which of these equations are perpendicular to this one? So again, I'm going to use my -a over b, and I'm going to get -2 over 3. So if I want it to be perpendicular, I change the sign, and I flip it over, and this is the slope I'm looking for. So which one has a slope of 3/2? This one. So that's the one that's perpendicular to that line. Okay. Let's try a few more. So which equation represents a line that is parallel to this line? Well, it's not quite in any of the forms, so we need to move we need to get y alone by adding 5x to both sides. And when we do, we find out that the slope is 5. And since it's parallel, I'm looking for a slope of 5. So which one has a slope of 5? Well, this one right here. So I'm going to check that one. All right, this one says, hey, what's the line? Which one of these lines represent a line that is perpendicular to this line? Okay, perpendicular means I have to do some work. I have to change the sign and I have to flip it over. But now when I look at these equations, they're not in the form I'm used to, right? They're not, well, they're not in the form that's most convenient for this. So they're all in standard form. I have to find the slope of each one till I find one that's -3/2. So I'm going to use a shortcut. I'm going to use the negative a over b. And that would get me 3/2. So that one is not perpendicular. Okay, we'll go over here and we are going to get, oh no, be careful. Do you see the y's first here? So it's -2/3. So that's 2/3, not ours. Now we've got to go to this one. We're going to do -2/3. Must be this one then, -3/2. And as you do more of these, you probably will get to the point where you say, oh, okay, if it's -3, that's the coefficient of x. I need the opposite of, the opposite of that, and then the denominator is my coefficient of y. You might get used to that, so it's a little easier. All right, 2 more. Which equation represents a line that is parallel to this line? So I'm looking for a slope of 2/3. Again, I got to go through this all and figure it out. So this is going to be -3/2 when I do my a over b, which is 3/2. This one's going to be -2/3. This one's going to be, watch, this is the x. This is going to be 2/3. So there we go. As this one would be -3/2. So we have found our line. And one more. Last one for today. So we're looking for perpendicular. So we've got to go y equals 5x minus 6. So our perpendicular slope would be 1, the flipped over version, and the opposite. So the opposite reciprocal is to 5 is -1/5. So do you see one? These are all nice and pretty for us in slope-intercept form. So this was pretty easy right there, -1/5. All right, good luck with your slopes and equations. M squared signing out.